Hello, welcome to our weekly podcast. And this week, we're going to be resuming our previous chat, the first one, the first episode we had with Cédric. So we're very happy to have Cédric back and for the continuation of the CAS.io discussion and demo. So,
Yeah, Cedric, welcome back. It's great to have you. I know we had a bit of a break last week, but Mary and I have been like flying all over. Actually,
It's,
Mary's been flying all over. I just flew to New York and back.
yeah,
So yeah,
that's
Yeah,
right.
it's always good to be here, back here, and we
Hmm.
discussed a lot of things 2 weeks ago. So
Right.
Yes.
not bad that people has actually 2 weeks to go over the sample and do code by themselves.
Yeah.
Yep.
Uh, Hopefully today you've caught up because we will start right again where we left.
Yes. Yes.
Well,
That's
excellent.
great.
Yeah,
Yeah, we're looking
take it
forward.
away, Cedric.
Yeah. All right.
Okay, right. Right. Let's go. So let's start week 2. During week 1, we actually explained what was LLM providers and OpenAI. We created an account both on DataStax Astra and OpenAI, and we built a little Spring Boot unit test that was directly using the Java client coming from OpenAI, the one that you find when you go to the OpenAI documentations. Actually, now there are multiple. It's not the only one. There are OpenAI for J, and I will even use another one today, totally part of the global framework. We also introduce you Astra SDK Vector with everything needed to use Astra as a vector database. But here, what we don't like is we are directly connecting to OpenAI. We would like to have a kind of abstraction. If tomorrow we want to move from OpenAI to something else, what should we do? So there are frameworks out there to help you do what you want to do with AI apps. So, question: what do you want to do with AI apps? So here on the left part, I put an AI-powered app, chatbot, AI assistants, copilot. Everybody's doing that now. Search engine, recommendation engine. But if you open that app, what do you get? You get actually features like prompt template. You have a fine-tuned prompt that you send and you want to get better result. You have RAG, as we did last week, retrieve augmented generation. You ask a question based on the context you have loaded from the database, or LLM story. You want to see the chat, the history of your chat. And if you open this again, well, this is the low-level features, technical features that you are actually expecting when you're interacting from AI with the database. First, it's all about caching. You want to key value cache. You want to cache everything that's possible. Semantic cache, you want to cache the output if the user asks twice the same question. Obviously, you don't want to do all the computation again. You want to save everything that can be saved. So the memory, the settings, and finally, you want to do search. Two types of search. One is the similarity search that we did last week, which is actually computing the distance in between two vectors just to find what are the closest set of sentences close to your request. And the last here is metadata filtering. So not only you want to get data close to what you ask, but also you want to provide in the where clause something else. Where user is my user. You want to adapt the search to the connected user, for instance, or to one particular product. You don't want to search on the whole data set. And this is why you introduce some keys that you can search on, and those are called the metadata filtering in the world of vector search. You can even, on top of that, add keyword search, but that would be probably for week 3. As of today, let's stay that. So if you look at those low-level functions, you realize that, oh, maybe we could find a standard standard interface like JDBC for Java? What if you could have the JDBC for vector database that multiple database provider will implement, and you as a developer, you only have to import a JDBC jar. It will always be the same way to execute queries. Well, that's what emerged in the Python world with multiple frameworks. So the three main are LangChain, Llama Index, and Semantic Kernel from Microsoft. With LangChain, like 80% of the market, Llama Index 15, and Semantic Kernel 5 to give you an idea. And it's super active on the Python community. But here, what we are doing is all about Java. So what about Java?
Right.
Well, no surprise, Java pickup. We have some conference this week at Devoxx Belgium, exactly talking about that. LangChain has been ported for part into the Java world, and it's called LangChain for J. So if now I'm going back to the week 1 recap we had, so let's dump OpenAI Java client and put another LLM. Just to see what this looks like. Okay, so we trash the OpenAI client. Eventually, we want to connect to another LLM like Vertex AI, or Hugging Face, Azure OpenAI. So now I say we have this abstraction LangChain 4j. Boom. And now LangChain 4j will be there to create something called the model, a LangChain model. And this is the model that we will use to interact with OpenAI. And it will be actively the same class to interact with Vertex AI, just different implementation. So same
excellent.
interface, different implementation. And what you did to connect to the rest of the world, for the database, it's the same. The database in the generative AI world, it's called a vector store. So the class have vector store, and as a database provider, you need to implement this LangChain dash here Cassandra, that is the support for Cassandra as a vector store. But today in LangChain, you will find Milviews, Weaviate, Pinecone, ChromaDB, and others vector DB that you might have heard. But none can scale as good as DataStax Astra, right? So let's see what you can do. And with these, 8 million in, slides are cheap. Let's go to the code.
That's right.
Okay. So first, LangChain 4j, you can find that on GitHub. 0.23.0 has been released last Friday. You have a lot of samples over there. Code, so multiple embeddings, including a lot of open source embeddings already. Here you can see all the store available. So multiple vector store and multiple LLM provider. And it's in the middle doing the algorithms and providing the interface. And this is actually why everybody is doing LangChain in that way. I set up a little website for the LangChain project documentation, but it has not been adopted yet. So it's a pull request. I hope those guys will accept my work, and we will improve a little bit the installation. So totally coming from Awesome Astra if you have already used that website.
Nice. I was wondering about that because this looks like the Awesome Astra,
totally,
document.
but actually it's not. It's a website LangChain built with Material UI.
It's its own thing,
and
huh?
MKDocs. So totally open source. So why not? So as last week, we will reuse this GitHub repo on DataStax dev as usual, called Demo Generative AI with Java. I reorg a little bit the source. So now we have week 1 and week 2. Okay, no surprise. And I added this week 2 over here. And we will just do setup project, ingest, and chat completion. It will be fast. We will not take 1 hour. Okay, so code. So here, if I open week 2, we are creating a Spring Boot project. So as usual, we go a Spring Boot starter. So we are using 3.1.4, and I'm using Java 21. Of course, right? Of course, you
Of course
should
we're on
use
Java
Java
21.
21.
Yeah.
Come on, it has been LTS 2 weeks ago. Let's use it. Let's use it. It's LTS. Then here I'm importing long chain Cassandra. Of course, that's what you should do, long chain Cassandra. And here I had to actually force the Cassandra version, because you know how Spring is. We need the latest version of the Java driver to get the support of vector.
Right.
Okay. What is missing here? You might think we don't have the Astra Spring Boot starter anymore. And you're right, you don't have to. It has been kind of wrapped into the long chain Cassandra on its own. So now you don't even have anything to do.
That's pretty cool. Yeah. I was thinking that actually. Like, oh yeah. Where's the Astra starter? But okay, yep. Go ahead.
Exactly. And so if you look now in the settings, of course you don't have the whole block of settings coming from the Astra starter. I just created my own keys just to set a database name, a key space, and a table. Because my test, the test you have here and you will run on your machine, will create you the database if you need. I also improved quite a lot something called Astra SDK DevOps API. So now you can really don't think about creating DB on Astra. It's done for you. And I will show you with the code again. My goal is really to simplify as much as possible.
Yep.
Okay, so now the main. Okay, last class, nothing special. I had to tell Spring Boot, don't mess with Cassandra. Cassandra is in the class path, but don't care about it. So I exclude what they call the auto configurations from the Cassandra world.
Gotcha.
Okay, so now single class. It's a big class. So here, first, I'm getting the Astra token. So as last week, the Astra token is on your machine with Astra DB application token. If you don't recall how to get that, I remind that in the 12th setup project. And the cool stuff is, look at the nice JUnit annotation I found out not so long ago. The unit test will be executed only if the environment variable is set. I found it super handy because sometimes you are doing GitHub Action or CI/CD and the environment variable is not set, or you cannot use it. Well, this test is skipped, so that's pretty cool. And here is the magic. So database ID, setup database. See this method called setup database? If the database does not exist, it will be created. If it's hibernated, it will be resumed. If the key space does not exist, it will be created for you. And it's a blocking call. So as soon as this setup database is finished, you can be sure that your database is active, your database exists, have an ID, and you can use it immediately. Let's set up LongChain. So LongChain have two parts, right? The model to talk to OpenAI and the store to talk to Astra, and is just in the middle. So the first part here is initializing the model, talking to OpenAI with a OpenAI model builder. And we are in Java, everything is fluent and builder. And for the store, Astra DB store, token, database, table, same. And this time the builder is on me. But it's pretty similar, right? And when you have both set up, well, you can start using them. So part 2 of the test is I will just focus on OpenAI. I take a text file and I'm using this OpenAI model to populate the store. So I'm using something called an ingestor. Everything is done for you. All the classes are there. So you want to ingest, just use the ingestor. The ingestor will take a file input and the store. And here we are using something called a document splitter. Very, very important for you if you want to go into generative AI. When you are working with a model have a finite amount of token input and output. So when you load a big file, a big text file, you cannot load the whole file with the single call. You need to split.
Gotcha.
This is based on max token that the model can use. And max token 100 in OpenAI is something that you might want to use. And how do you want to cut? It's not like cut at every sentence and send data that have nothing to do one to each other. And this is why using LangChain is clever, because in the document splitter, there is some NLP to cleverly split a sentence to group the bag of words with the same meaning, if you wish.
Sure.
So
I was wondering that actually. Yeah. You know, that's one of the things that you know, as far as like, you know, Gen AI goes, is understanding like strategies for like chunking and splitting. Yeah, that's something that I need to learn more about.
Yeah, exactly. So it's called overall transformers. You know, Autobot Unite. So easy to remember, right? So it's called the transformers. And yeah, this one is a splitter using a recursive method to split what is okay. And there is some overlap in between what they call the chunk. And here you have set up what is the overall overlap in between two chunks. You know, and the less chunk are the more randomized it would be, because you know it will be hard to tell that those were part of the same block before that. But if you provide some overlap, then all of a sudden your RAG could get a group of sentences which were part of the same paragraph, and that would be pretty useful in your request.
Gotcha. Okay.
So here I'm embedding and populating the table. And the last piece is I will now doing chat completion. I ask a question. Oh, by the way, I loaded a file, which is a text file, which is a story about a happy carrot. And it's all about Charlie was a radiant carrot, always beaming and with joy and positivity. So it is the story of Charlie, who is an happy carrot. And I'm actually asking something that without RAG would have no sense. If I ask OpenAI, who is Charlie, you know, out of the blue, it will tell me I have not a clue. Actually, we just hallucinated and provide me a weird answer. But here, the idea was to show you that when I ask the question to OpenAI, it is actually taking into account what I've provided. So here what we are working is, so first, we are taking that sentence and creating a vector, you know, vectorize. So here we are using the embeddings method to embed and create the vector. So here, response embedding, question embedding, that is your input vector. And then you are just using the store. Find relevant is something that you need to understand as similarity search or search. And so what you provide as search is your vector, max result, you know, how many sentences do you want to get close to the vector, and the mean score, meaning that you know, even if you have, you know, in case you have very low amount of data, if you do not provide a mean score, you can retrieve something that are totally not relevant. So if I ask you, give me 10 answers, but you set a threshold, a mean score at 0.8, maybe it will only get you 3 items, but it's not crap. It's a way to improve the quality of your outputs. And then, so here there is a prompt template, so the final call to real OpenAI. So answer the following question to the best as you can. So that's the question I will ask. And based on the information, and this information is what is retrieved from the vector store. So here, what is retrieved from the vector store? Relevant embeddings. And this is what actually I've swap. You know, I swap the key with the value of these relevant embeddings. I add it all together. I make a big joint of all the chunk, and then I replacing info by my chunks. And so now I can simply apply the variables to the prompt template. Prompt template, it's like a prepare statement. And here I passing the variables. And then I actually apply, and now I have a bound statement if you're into the Java in the Cassandra world. And
very nice.
Yeah, now you can go. So now you are instancing a chat model, which is different from the embeddings model. The chat model is GPT 3.5 Turbo, maybe the one you are more used to. GPT-4, GPT 3.5. Those are just chat completion model. Previously, we used something called Text Advanced 3 or 2, maybe here. Compute, text embeddings ADA 2. That was the name of the model we used to compute the embeddings. So 2 different models, not for the same purpose. And so finally, I generate my response and I just show the result. And I will now click that button and see if our test is okay or not.
Yep. So it's who is Charlie, huh?
Yep. Who is Charlie? And yep. So based on all right. So it's starting. All right. Okay. So here you can say that we are still using Astra Client, but you have never heard about Astra Client. Everything is done for you by LangChain. And it's like a Russian doll. I create the connection that I wrapped into an Astra client, that I wrapped into the Astra Vector, then I wrapped into LangChain Cassandra. And the only thing you have to provide is the token.
Right. And it just does it. Yep. Awesome.
And here, so the connection has been established. Then it's created what it needed. So table story, IDX, and the index associated. You need 2 index on the table. And then is creating the embedding store, splitting, loading, and so this is the final answer. Based on the given, Charlie is a person who has a diverse group of friends, each of whom is a vegetable with their own unique characteristics. And that's Charlie, our happy carrot.
Yep. Well, there you go.
Yep. And I think with that, it was my little demo.
No, that's cool, Cédric. Yeah. I will definitely step through this. It looks like the steps for week 2 that you put in here are are much more simplified than what it was in week 1. So I'm kind of curious to look at the table myself and see how that turns out.
The more we are making progress, the simpler it is. As of today, I'm still using the Cassandra drivers to integrate with Astra. But in Astra now, we have a REST API to expose even simpler function, just similarity search as a REST resource. So with that, I can actually change my client not to use Cassandra directly and building the SQL queries myself, but I can go directly with the API, and actually you can use any language to interact with that. You don't need a Cassandra drivers anymore. So what I've prepared for you next week or the week after, depending on what you do, is probably an agent. And maybe showing you the JSON API and no more Astra connection.
That would be really cool.
That sounds great. Yeah. Thank you. Thank you so much.
Cédric. This has been awesome. Yeah. Mary, do you have a QR code you want to run over my face?
I was going to say, I just updated that. So here it is.
It goes over my face. Yeah.
Yes. So yes, it is our Astra DB free trial with Vector Search. And so, thank you. Okay. All right. I will hide it so we can see Aaron again. Okay. Awesome. So thank you again, Cédric, and thanks, Aaron. And we'll see you next week. So,
all right. Hey, thanks everyone. Bye-bye.
See you.
Bye.
Bye.